Now that we've noticed that on a straight line demand curve, there is different elasticity levels, let's see what the implications are for profits. If here we abstract from the case that we have costs involved while selling a product, if our goal is simply to maximize total revenue, there is going to be a simple condition to maximize total revenue. When I think about total revenue and I kind of forget how to calculate it, you always want to think about how would you calculate total revenue if you were to be selling lemonade at a lemonade stand. So some people are a little rusty when it comes time to calculate total revenue, but when you think about it, the simple pieces of information that you need to know how much money you made in a given day, how much revenue you made in a given day, you have to ask yourself, well, how many units did I sell and at what price? And if you've sold 100 units at $2 each, well, 2 times 100, you know that you've made $200 worth of revenue. This is what you're trying to maximize. Here, graphically, how would I represent total revenue? Well, total revenue could be represented by the same kind of idea here as price times quantity. So if I think of my price times my quantity, well, how could I represent my price? So if I were to say, let's say I'm here, I'm at point A, what is my total revenue at point A? Well, some of you would say, well, at point A, my price is 2, my quantity is 10, therefore my total revenue at point A is 20. How did you do this? Well, total revenue is simply price, the price that we have, and from 0 to 2 is that distance, times the quantity, it's this distance here. So I could say that my total revenue is this area here. This whole area represents my total revenue at point A because I'm multiplying 2 times 10, and this rectangle is my total revenue. So which point along this section here would yield the highest total revenue is the question. So if I go back to another diagram, let's say I were to ask myself, well, what happens to total revenue if I'm in the inelastic portion and the price goes down? Okay, so let's say I'm in this portion here and I have my price go down. So it's gone down from 2 to 1. So throughout this process, I could see that if I go down to 1 instead, I will now have this area here as my total revenue. Therefore, initially I had this area, and now I have this area and this area. Okay, so initially I had A and B, and now I have B and C. So I could see that dropping my price from 2, price goes down from 2 to 1, will actually lower my total revenue. Okay. And here, if I recall right, I was in an inelastic portion. Simply saying that in an inelastic portion of total revenue on my demand curve, I can notice that as the price goes down, my total revenue will fall. What could be the explanation behind this? Well, I'm in a portion that I've decided to drop my price when I know that people are unresponsive. And if I know that people are unresponsive, or if I didn't know, now I do know that people are unresponsive, it means that even though I drop my price by half the amount as before, I do make extra revenue on extra units sold, but my loss of revenue on the previous unit sold that still gets sold, that loss of revenue on those units that people were still willing to buy at the higher price does not compensate for my additional revenue on the extra few units sold. So that dollar times the 10 units that were already sold, this $10 that was lost, is not compensated for by this 2 units at $1 that are sold more now. So in this specific case, if I were to calculate it out, I could say that there's been a drop in total revenue of $8. Okay. What happens if we were on the other side of the equation, or on the other side of the graph? Let's say I'm up here instead, and I'm going from here, I'm at point B, and this is my current total revenue at point B. And I were to look at what would the total revenue be like at point C. Well, I could see now that, let's say my total revenue was initially D and E. Well, I could see that F is greater than D, therefore my total revenue goes up, going from B to C. And this is due to the fact that here, up here, we said earlier that people are responsive. They're responsive to a change in price. So we've dropped the price by roughly 20%, and we've seen about double the amount of units sold. Therefore, we could say that even though we've lost revenue on those previous units that were sold at the higher price, that dollar times 2 units or whatever is compensated for by the fact that now at this lower price, I managed to sell, let's say, 2 more units at $5, so I've managed to compensate for that plentifully. So in this case here, my total revenue goes up. And in this case here, my total revenue has gone down. And in both cases, from a decrease in prices. So if I'm at a high price, my intuition would say for a high price, drop the price and you will get a higher total revenue. But if you think about that and you think, well, I'll keep dropping the price and dropping and dropping and dropping the price till I get close to zero, it's not true that total revenue will keep going up. There's going to be this threshold point where if you keep dropping, you're going to fall in this situation like we just had here, the first of the 2 situations where as you keep dropping, your total revenue is actually going to go down as you drop the price. Therefore, there has to be this sweet spot. And this sweet spot where total revenue is maximized is when we have a situation of unitary elastic demand. And in our previous scenario, the situation where we had unitary elastic demand was between these 2 prices. And you can notice if you were to calculate profits or total revenue at each of these points, here I have 0, here I have 12, here I have 20, here I have 24, here I have 24. Therefore, we are at that maximum point of total revenue of 24. And if I keep going with a higher price, actually this was about to start falling again. So unitary elastic situation, this situation here is the situation that maximizes my total revenue.